Hey everybody, this is Walter with Access Electric, and today I wanted to talk to you about how to start a VFD drive with a 2-wire start. It's pretty simple. First you have to program your VFD to accept the 2-wire start command. On this VFD, it happens to be parameter 36, which gives you the start command. And all you really have to do, so I have power onto my VFD. My VFD is already wired to my motor. And all you really have to do, once you program your drive, it doesn't matter what kind of drive you have. It could be an Allen Bradley, it can be an ABB, it could be AC Tech, it could be anything. But once you program that for a 2-wire start, really all you need is to close 2 wires and the motor will start. Now, I've been asked, let me let that die down. I've been asked numerous times, how do you use a start-stop with a VFD to start a VFD? And so here, I've got my VFD set up with my 480 volt coming in, my 480 volt going out to my motor, and it's all by itself. And here I have 2 wires that I'm going to use to start this VFD in the 2-wire start command. And these 2 wires are coming from this ice cube relay. I have a separate 110 volts that is coming in. It's feeding my stop button which is normally closed, then feeds my start button. My start button is normally open, so that means no power is going through it. Once I press the button, it heats up the coil on my ice cube relay. And then I have my holding contact. This is hot all the time because the stop button is normally closed. So this is hot all the time. It comes over to one of my contacts, one of my common contacts on my ice cube relay. And then when the ice cube relay closes, this becomes energized and it keeps itself on. So that's how I bypass the start button with this loop right here. I'm bypassing the start button. And then once I turn that on, these 2 wires close. So let me demonstrate. Here I have my ohm meter tied into my 2 wires. I'll hit start and my ohm meter is going off. I hit stop, my ohm meter stops. So once I hit start, my ice cube turns on, it stays on until I hit stop. Now I'm just going to use the same exact setup. I'm going to take these off. I'm going to turn that off. There's no power on it because these are low voltage. These are going to be low voltage isolated wires. I'll take one of these on this particular drive. It's number 11 is my common. So I'll take it to number 11. And if you see this little yellow jumper here, this little yellow jumper is an enable for this drive. So if that jumper is out, the drive will not run. So we'll leave the jumper in there. And this is going to go to number 2, which is my forward start. And so now, if I turn my control power back on and I hit my start button, my motor will come up to full speed. Now I have this set right now almost at 60 hertz, right at 60. I have a maximum speed of 90 hertz set to this drive, and I have a minimum speed of 20 hertz set to this drive. So that's the slowest it'll go on this drive. Now that's all programmable inside the drive. So for your application, you want to figure out what your lowest speed will be. Be careful not to burn up the motor if you go too slow. But there you go. There you have it. That's how you use a 2-wire start-stop with a VFD drive. Let me hit stop, and the motor will ramp to a stop. Those are all programmable settings inside your drive. One other thing to consider, one other thing to think about is I have the separate 110 going to my start-stop. You never want to use this 24-volt low voltage control. You never want to put that in the same conduit as your high voltage 240 or 480 volt wiring. Sometimes I've seen where I go on a job and somebody else has done the job and I go behind them and the drives are having trouble, and I notice that people will run their low voltage through the same conduit as their high voltage. Well, you got to remember, electricity creates inductance, and inductance is going to put voltage onto those low voltage wires, which may cause your drive to start or stop at times when you don't want it to start or stop. It could damage your drive, it could injure people, so you don't ever want to do that. But one other thing you need to think about, it's not good to turn, if this motor, I don't have a disconnect here on the load side of my drive, but typically you will have a disconnect before the motor. You always want to make sure that if that disconnect is turned off, it turns off the drive. You could damage your drive by opening a disconnect on the load side of your drive if the motor is running. So what you want to do is you want to take your 110 volt that feeds your stop button, take it out to your disconnect with your 480 volt. You could run that in the same conduit, 110 and 480. Run that through an auxiliary contact in your disconnect, then run it back to your stop button. So if the disconnect is off, it's the same as pushing stop. So if the motor is running, and we'll let that get up to full speed. If the motor is running and you go out to the field and you need to work on this motor, or you need to, an emergency, you need to shut off that motor, you can turn off the disconnect, and by turning it off, it'd be the same exact thing as pressing that stop button. You're going to lose all power to the motor, and you're going to lose the controls that went out to the motor, or went out to start the drive. So it's going to turn off, the drive will look at it just like a regular stop signal, it won't damage the drive. So there you have it. That's how to use a start-stop system with an ice cube relay to start a drive in 2-wire start mode. If you like these videos, give us a thumbs up. If you'd like to, subscribe to our channel. And until the next time, have a great day.